Hello. Here is your lesson for Unit 2, Lesson 2, which is translation. So just a couple reminders. First of all, tonight your homework, Unit 2, Lesson 1 is due. This homework will be due on next week, Monday. And then don't forget on Monday as well, the next time I see you, we're going to have a concept check over Lesson 1. So Lesson 1 was all of our reflection stuff, okay? Okay, so today we're talking about Lesson 2 of our transformations. So we're going to talk about translations today. All right. Okay, so let's talk about translations. And by the way, even blocks, your concept check is still going to be on Monday because it's an all day, but your homework will be due on Tuesday of next week. Okay, so our learning intentions for this class period is that I am learning to experiment with isometries in a plane so that I can understand congruence. So if you recognize that that's the same learning intention that we had the other day with reflections, it's still this idea that we're playing around with isometries in order to get an idea of what's going on. All right. Today's success criteria is to translate a figure using vector and coordinate notation, to perform composites of transformations and describe the resulting transformations, and describe a sequence of transformations that maps one congruent figure to another. Okay, so let's get started. So take a moment and pause the video and think about what type of transformations do you see in this graph, in these two graphs. So pause the video, check them out for a second. Okay, hopefully you said translation, right? Because I didn't change my orientation at all. I didn't change my size, right? So I know it's not a dilation. I didn't change my orientation, so I know it's not a rotation, and I know it's not a reflection because I didn't change my orientation either. But I did slide it, right? I slid this one over and down. I went the wrong direction there, right? Pay attention. This is my pre-image because it's just R. This is my image because it's R prime. So I went up and I went over on this one, correct? If I look at this one, my pre-image is K. My image is K prime. So I went left and I went down. So translation. So that's what we're going to talk about today. But before we talk about that, let's see where we're coming from. So the other day in class, we talked about reflections, okay? And remember, I said we're going to have a common theme throughout all of these transformations, and that is that we have a direction and we have a distance. So the other day with reflection, our direction was always perpendicular, right? Perpendicular gave us the direction to get us to our midpoint. And then we used our change in y and change in x to go over to our other point that we are missing the same distance away, right? To create that midpoint, to create that line of reflection to be a perpendicular bisector. So today, let's see how distance and direction help us with translations. So today is translations, again, not to be confused with transformations. Transformations is the whole family. Translations is this slide idea. Okay, so what is a translation? So a translation is an isometric transformation that moves every point of the figure the same distance and the same direction. So it moves every point of the figure the same distance and the same direction. Okay, so every point. So that's why we just call it a slide because we're not turning it, we're not flipping it, we're not doing anything. We're just sliding it the same distance and direction all over the graph. Okay, now what is that distance and direction? So the direction is that if there's a change in X, we're moving the graph left or right. And of course, that's because my x-axis is my horizontal axis, right? So if I have a change in my x value, then that means I'm shifting my figure left or right. If I have a change in my y value, then that means I'm moving up and down my y-axis, or I'm moving up or down horizontally, okay? So if I have a change in x, I'm moving it left or right. If I have a change in y, I'm moving it up or down. The distance is just the same distance, okay? So it's going to be the same left or right, and it's going to be the same up or down, all right? So if I move 1 point, left 3 and down 4, I'm going to move every point left 3 and down 4. So the big thing is that we just do the same change in x and change in y, okay? Okay, now translations as a transformation are actually pretty simple, pretty straightforward. However, there's lots of ways that we can present this, and there's lots of ways that we can communicate this. So, a couple ways that we can communicate transformations. First of all, and I have an example over here. If you look over here, we are letting B or A, B, C, D be our pre-image and we're letting EFG be our image, okay? And so if you notice in this picture, we go 7 to the left and we go 9 down, right? So that's what's happening. That's our translation is 7 to the left and 9 down. So we have three different ways that we can represent this translation. The first way is in words, okay? And that's what we just did, right? We're going to translate 7 units to the left and we're going to translate 9 units down, okay? Notice that in words we get a distance and we get a direction. Our distance is the numbers, our direction is the left, right, up, down, that kind of thing, okay? Our other option is a vector. Vectors are new, but what vectors do is vectors tell us a distance and a direction. So notice they're a little bit different than points. Points typically have parentheses. Vectors have these like inequality signs almost like, okay? So they're like a hard bracket almost, okay? And you say, okay, well, but Miss Horn, that's just numbers. Well, why it's different is because it has those little arrows on the end, it's not an ordered pair. It's not representing a point. It's representing a distance and it's representing a direction. So the fact that here I have -7, that's in my X value. So that's telling me my X is going to go down 7. Why do I know that I'm sorry, not down, X is left or right. It's going to go left 7. So my X is going to go left 7. How do I know I'm talking about left? Because of the negative. Okay. If my X is negative, that's talking about left. If my X is positive, that's talking about a right. So in this instance, your positive and negative is not talking about the actual number, it's talking about the direction. So then when we look at -9 is my Y. Negative means I'm going to go down. 9 means the distance I'm going to go is down 9. Okay, so again, if my Y is negative, that means I'm going down, and my X is positive, that means I'm going up. Okay, so in other words, any negative numbers either mean left or it means down, depending on which one you're talking about. Any positive numbers means right or up. Okay, so again, this is not indicating an ordered pair. The little inequality brackets, I don't even know what to call those V brackets. Let's call them V brackets. So those little V brackets are indicating that it is a vector. So the vector, that number is representing the distance through the number and it's representing the direction through the sign. Okay, our other option in order to write translations or communicate translation is what's called a coordinate rule. Okay. And in a coordinate rule, what we do is we write we say, okay, X comma Y. So if I start with any point X, Y, then it's going to translate. And there should be a little arrow here. My arrow dropped down on my screen here. There should be a little bit arrow. So it's going to translate to X -7, X -9. So the idea is with this is we can use our actual coordinate points. So for example, A is 1, 3. So A is 1, 3. So in this case, A prime would go into this formula. So A prime would be 1 -7 and 3 -9. And again, what this is saying is the -7 means I'm taking my change in X is left 7. And my -9 is telling me that my change in Y is down 9. Does that make sense? Okay. So again, just like the vectors, the sign is telling us our change in direction because remember, our change in X in this case is -7. Our change in Y in this case is -9. So this is telling me -9 and -7. So that means that A prime is going to end up at -6, -6. Okay. And if we look, sure enough, A prime is supposed to go with, I covered up, it's supposed to go with E, which is down there. And sure enough, that is negative six, negative six. So coordinate rules kind of give us a kind of almost like an equation to put our points in order to translate them. Okay, so words give us distance and direction in words. Vectors only give us distance and directions, but coordinate rules give us almost like a formula in order to translate the problem. Okay. Okay, so let's try some of these. So on our first example, I want you to take a second. I want you to pause the video and I want you to try this example by yourself or with your table partner if you guys are pacing together on the video. Okay, so pause and try this example in your notes. Okay, so on this example, I gave you a vector. Okay, so the vector that I gave you is 2, negative 5. And again, you know it's a vector because it has those V brackets, right? Okay, so let's understand what this vector is saying. So this vector is saying this is in my X position. So this vector is saying that my change in X is going to be a positive 2. Or in other words, it's going to be right 2. Then I have negative 5. So negative 5 is in my Y spot. So this is talking about my change in Y. So my change in Y is going to be negative 5, which means it's going to go down 5. Okay, remember, left, right, right is positive, left is negative, up, down, up is positive, negative is down. So then I'm going to do that with every single point. So I'm going to start with my A, and I'm going to go, my change in X is right 2. My change in X is right 2. And then I'm going to go down 5. 1, 2, 3, 4, 5. So I end up right there. So my A prime ends up right here. And I'm going to do that for every single point. So I'm going to go, oh, you know what? You guys, I did that wrong. I don't know my right from my left. I need to do right 2, which would be this direction. And then I need to do down 5. So my A prime ends up here. And then I'm going to do that for every single problem or every single vertex. So I'm going to go right 2 for my B. I'm going to go down 5. So then that becomes my B prime. Remember, make sure you're labeling your points so that everybody can see where they move. So we're going to go right 2, and then we're going to go down 5, which should take us to the end. So then this is my C prime. And then again, don't forget, it's very important that we connect the dots. If we don't connect the dots, then we're not translating the whole figure. We're just translating 3 points. So we want to make sure we connect the dots. Okay. So again, like I said, translations are pretty self-explanatory. They're pretty natural for us to do. The biggest thing is understanding how we can represent them, okay, with vectors and coordinate rules, etc. Speaking of coordinate rules, let's look and see how a coordinate rule would work. Okay, so here I said if A is negative 2, 3, and B is 4, negative 1, translate AB using the coordinate rule xy goes to x plus 3, y minus 5. So my coordinate rule is to say xy goes to x plus 3, y minus 5. And again, the whole idea behind this rule is saying that you can take any point xy, so any point xy, and you're going to add 3 to the x. Your change in x is going to be 3, and your change in y is going to be negative 5. So we can go straight to our graph, and we can go ahead and do that, right? We can do a change in x. This would be a change in x is 3, so write 3. This would be a change in y, which would be negative 5, so down 5. So we can go to our graph and we can go ahead and do that. Or our other option is we can go ahead and take advantage of actually the formula. So the formula says that A, which would be negative 2, 3, should translate to A prime, which is negative 2 plus 3 and 3 minus 5. So notice I'm just putting in my point here into the formula, okay? So that means A prime goes to 1, negative 2. So A prime is going to go to 1, negative 2. So notice I knew where A prime was without doing anything on my paper, okay? And then if I do B, okay, so no, wait, pause. Pause the video. You translate B using the rule. Okay. So translate B using the rule. Pause the video. Okay. When we translate B, B is going to be 4, -1. So that means B prime is going to be 4 plus 3 and -1 minus 5. So that means B prime ends up at 7, -6. So if I plot 7, -6, I end up right here. So here's my B prime. And again, we got to make sure that we connect our dots so that everything gets connected. Okay. So again, kind of the purpose of the rule is that we don't necessarily have to do it on the graph. We can get the points. We can figure out what our image points are using our pre-image points and using our rule. That gives us our image points, and then we can go to the graph. So it's kind of like doing it a little bit backwards. Okay. Okay. Speaking of backwards, let's figure this out backwards, okay? So here it says describe the translation, and I want you to describe it in all three methods. So in our words, in our vector, and in our coordinate rule. So what I'm going to do is I'm just going to pick a point to focus on. So if I pick, let's say, H to focus on, then I'm going to look and see where H prime went. And H prime went right here, right? So if I notice, then that means that my change in X and direction matters. It's important to know where H is versus H prime is. And always know that you're going from H to H prime. You're always going from the pre-image to the image. So when I go from H to H prime, my change in X is -2. I go back 2. And my change in Y is to go down 2. So my change in, I'm sorry, down 1. So my change in Y is to go down 1. Okay, so in words, I'm going to go left 2, and I'm going to go down 1. In vectors, so vector, I have the little triangle bracket or the V bracket. And then it's my change in X, which is -2. The negative tells me to go left with my X. 2 tells me how far to go. And then my change in Y, which is -1. So negative tells me to go down. 1 tells me how far to go down. Okay, last but not least is my coordinate rule. When you write a coordinate rule, you always start with a generic point. So XY, you'll always start with XY goes to. So it's a rule. It's telling you what to do. So you have to talk about where you're starting. So you're starting at XY, and then I'm going to take X and I'm going to subtract 2 because my change in X is 2. And then I'm going to take Y and I'm going to subtract 1 because my change in Y is -1. Okay, so notice all three of these methods are very, very similar. They always come back down to your change in X and change in Y. And your change in X and change in Y tells you a distance and it tells you a direction. Okay, now that we've done one together, I want you to do this one on your own. So a triangle has vertices at A4, 2, B3, -2, and C1, 1. An image of the same triangle has vertices at A prime, -1, 5, B prime, -2, 1, and C prime, -6, 4. Describe the transformation in words in vectors and with a coordinate rule. All right, so pause the video and I want you to go ahead and try to write these. Okay, so when you're writing from a bunch of points, you really, just like our picture, we didn't look at every single point. We're not going to look at every single point here either. So we're going to focus on just A, which is 4, 2, and A prime, which is -1, 5. Okay. And we're going to see what happens here. So remember, all of this is about your change in X and your change in Y. So if I think about my change in X, now remember, change in X, we can either count out or we can subtract out. Change in X is the same thing as the vertical distance, right? So our change in X is the same as vertical distance. Our change in Y is the same as horizontal distance. And remember from Unit 1, vertical and horizontal distance we subtract. But the order that we subtract is very, very important, okay? So because we're trying to get direction as well. Remember, in the past, we wanted to always subtract so that our distance was positive because we were working with actual distance. Now we're working with change in x, change in y. We're working with vectors. We're working with all that stuff. So we want our sign to indicate which direction we're going. Okay. So in order to do that, we need to take our image point minus our pre-image point. So that means our change in x is going to be -1 minus 5, so -6. And if you think about this, 4 to -1 would be back 6, right? Not 6. I got the wrong numbers. Just kidding. I need to take -1 minus 4. Sorry about that, guys. So I need to take -1 minus 4, which gives me -5. And if you think about it on the number line, if I start at 4 and I go to -1, I am going back 5, right? So same thing with my change in y. So my change in y, my image is 5 minus 2, so I get a +3. And again, if you think about the fact that I start at 2 and I go up to 5, then that means my change in y was a +3, okay? So that's why it's really important that when we're calculating our change in y and change in x, it's always image minus pre-image. Okay, so then that means that -5 change in x means I'm going to go left 5, and then I'm going to go up 3. Then remember, a vector is just your change in y and change in x. So my change in x is -5. My change in y is 3. And then coordinate rules, the same thing, but in terms of coordinates. So x, y goes to x. And then if I'm going to start at 4, then I'm going to subtract 5 to get to -1. So x minus 5. Y, if I start at 2 and I go up to 5, that means I'm adding 3. Okay, so again, all of this is about change in x, change in y, distance, and direction. All right, but again, the sign now no longer represents a negative distance. It represents a distance going left or a distance going down. Okay? Okay, so hopefully at this point you feel comfortable translating a figure either using vector or coordinate notation. Okay, so we talked about vector is the little V brackets, and then coordinate notation is using that rule. Okay, last thing to talk about is compositions. Compositions. A composition is a sequence of transformations that map one figure onto another. So a sequence of a sequence of transformations that maps one figure onto another. So if we look at this, if we look at the images that I have here, notice we can see that like from here to here we reflected, right? But then from here to here we translated. Right? So that's a composition. It means that we did two different transformations in a specific order, okay? If we look at this one, on the second one, it looks like we probably reflected going this direction, right? And then it looks like we probably rotated going to my red one. That look about right? Or maybe it was a double rotation, something like that. Okay. Okay, so that's what we're going to talk about is a composition. So first of all, let's do a composition and then we'll practice identifying compositions, okay? So here it says graph the image of triangle ABC after a composition of the transformations in the order they are listed. So A is 4, 6, B is 6, 2, C is 1, 2, reflected over y equals -2x minus 1. Okay, so pause the video and I just want you to reflect right now. All right, so pause the video and reflect over that line. Okay, so if I'm going to reflect over that line, then I start at -1. I'm going to go down 2 over 1 for my line of reflection. Down 2 over 1. Down 2 over 1. Okay, so there's my line of reflection. Since my slope here is -2, then my perpendicular slope that I'm going to use is 1/2 to go ahead and get my distance, right? So 1/2 would be up 1 over 2, but in this case, if I go up 1 and over 2, I'm going to go away from my line of reflection. So instead, I'm going to go down 1 over 2. So if I go down 1 over 2, my midpoint for C is here. My my change in y is 1, down 1. My change in x is over 2. So down 1 over 2. So my C prime is going to be here. If I look at if I go down 1 over 2, down 1 over 2, down 1 over 2, my midpoint is going to be right here. So if I look, my change in x looks like it is 3. 1, 2, 3. And I'm sorry, my change in y is 3. My change in x is 6. So I'm going to go down 3. 1, 2, 3. 1, 2, 3, 4, 5, 6. So my that's A prime. And then my B, if I go down 1 over 2, down 1 over 2, down 1 over 2, here's my midpoint for B. So it looks like my change in y is 3 again and over 6 again, right? So I'm going to go down 3, 1, 2, 3, over 6. We'll put my b right here. So then I'm going to connect my dots. Okay, so there's my reflection. So now that I have a reflection, I'm going to take that reflection that I just did and I'm going to do my second transformation, which is a translation. All right, so now take the blue triangle that we just made. I should have done that blue, sorry. My blue triangle right here. We're going to take our blue triangle that we just made and we're going to translate it. All right, so pause the video and go ahead and translate the blue triangle. Okay, so let's look at the translation here. So +7 means I'm going to go right 7. +3 means I'm going to go up 3. So I'm going to take every point +7 up 3. Now, if I knew what the points were, I could plug them into the equation. I could go find the points A, B, and C and plug them into the equation. Or like I said, I can just use my change in X, which I know is 7, and my change in Y, which I know is 3. Okay, so change in X is 7. So I'm going to go 7 this direction. 1, 2, 3, 4, 5, 6, 7, and up 3. 1, 2, 3. And if I get a couple of these points off, I apologize, but my graph is really, really small for me to see. Now that becomes a double prime. Okay, so a double prime. So I'm sorry, no, that's C double prime, right? I move C first. Okay, then if I want to move A, I'm going to move A 7. 1, 2, 3, 4, 5, 6, 7, and then up 3. 1, 2, 3. So that would be A double prime. And last but not least, and I'm going to erase some of my work that I did before because it's starting to get really junky. So you guys can kind of see how the other day I said, I don't want extra stuff if you don't have to have it because there's lots of stuff going on here. B is right 7. 1, 2, 3, 4, 5, 6, 7, and up 3. 1, 2, 3. And again, if I got my count off on these or something like that, I apologize. Just make sure you have it correct. It's a really, really small graph on my side. So, okay, so there you go. There's my translation. So my final answer is the green triangle. Now, I want the whole blue triangle, all right, because that is part of the process, right? It's the part of the movement. So I still want the full blue triangle. I want to be able to see that in between. But my final answer is the green triangle. Okay, now let's try and go the other direction. So now I'm going to give you a composite and I want you to work it backwards. So describe a composition of transformations that will map ABC onto A double prime, double prime, C double prime. So a couple things I want to point out. First of all, I say a composition, so that means it needs to have two or more transformations. Okay, so I want to describe it. I don't want to describe it in one transformation. Okay, second of all, it says that it'll map triangle ABC onto A prime, A double prime, B double prime, C double prime. Now, since it's the primes, we know what goes with what, okay? But if it would have different letters, what this is just saying is that the first letter is going to match up with the first letter here, the second letter is going to match up with the second letter here, and the third letter is going to match up with the third letter, okay? So if I would say that like triangle ABC maps onto triangle XYZ, then I would be saying that A goes to where X is, B goes to where Y is, and C goes to where Z is. Does that make sense? Okay. Okay, but in this case, we have all the double primes, so we know what's going on. Okay, so I want you to pause the video, and we've only worked with two transformations, okay? We've only worked with reflections and translations. So you can do this, you can map these with just a reflection and a translation. So see if you can do that. Pause the video and try it. Okay, so the first thing that I see is that my orientation is off. So I'm going to try to put my orientation back together. Okay, so I notice if I let Y be my line of reflection, okay, if I let the Y axis be my line of reflection, then I can reflect C over here. I can reflect, so that'd be C prime, right? I could reflect B over to this side. And I can reflect A, that's 1, 2, 3, 4. So 1, 2, 3, 4. I can reflect A over here. So that puts me with a triangle right here. So that means that my first transformations that I'm going to do is I'm going to do a reflection over my y-axis. So I can say y-axis, or I could say x equals 0, right? Either one would work. Okay, so I'm going to reflect over my y-axis, or again, that's a vertical line at 0, so I could also say I'm going to reflect it over x equals 0. Then notice I'm really close to being together. Now I just need to move it up 2, and it should all match up, right? It should all match up if I move up 2, which means up is my y. It's up or down. So that's my change in y. So my change in y is going to be a positive 2. But notice I'm not going to move it left or right at all. So my change in x is going to be 0. So then that means my second thing that I'm going to do is I'm going to do a translation, and I'm going to write it in vector form, which would have 0, 2 as a vector. Okay, 0, 2 as a vector. Or you could write it as a rule. The rule would be xy goes to x, comma, y plus 2. So the x just stays x because I'm not adding anything. I don't have a change in y or change in x. Okay? Okay, so hopefully at this point, you feel comfortable with all of our success criteria. So we did the perform compositions of transformations and describe the resulting transformations, and we did describe a sequence of transformations that maps one congruent figure onto another. Okay, but we still have some notes left to take. So of course we have some extension to talk about. So again, I would like you to pause the video, and the substitute should have given you a little half sheet of an orange piece of paper that has this slide on it, okay? So I want you to do this transformation. So the first thing that I want you to do is I want you to sketch triangle ABC on the graph. Then I want you to sketch after you've made your reflection over x equals 3. And then the third thing you're going to do is you're going to sketch A double prime, B double prime, and C double prime after you've gone over x equals -3. Okay, so again, pause the video, and I want you to complete these 3 steps on that little orange sheet. And again, if you're timing the same timing with your table partner, go ahead and work with your table partner. Okay, so hopefully you've had a chance to do this, so let's do this together, okay? I'm gonna actually zoom this in so that I can look at my graph a little bit easier. Okay, so A is 8, 4. So 8, 4 would go here. B is 8, 0. It's important for us always to be labeling our points so we know where everything is. And C is 4, 4. So I have a nice, pretty right triangle, right? Okay, so the first thing I'm going to do is I'm going to reflect it over x equals negative 3. So I've already marked that for you. So x equals negative 3. That would take C prime right here. It's right 1, so it's going to take me left 1. A prime looks like it's 1, 2, 3, 4, 5. So I'm going to go 1, 2, 3, 4, 5 the other direction. And it looks like B prime is also 5 away. So B prime is going to go here. Okay, then I'm going to reflect again. This time I'm going to reflect over x equals negative 3. So again, I have that graphed for you. So I'm going to reflect over that green line. So that's A double prime. B double prime would reflect over to here. And then C is 1, 2, 3, 4, 5 away from my line of reflection. So I'm going to go 1, 2, 3, 4, 5 the other direction. So C double prime. So my final graph looks something like this. Okay, so now let's talk. What can we say about the movement from ABC to A double prime, B double prime, C double prime? So if I go from here to here, so notice I did a double reflection, back to back reflections. All right, and what ended up happening? A translation, right? I ended up with a translation. So a double reflection is a translation, but is it always a translation? What do you think has to be true for that to always be true? I want you to think about that for a second. Okay, I hope you noticed that my lines that I'm reflecting over were both vertical, which means they're parallel. Okay, so that brings us to one of our first theorems that we're going to do. It's called reflections in a parallel lines theorem. And it says if lines K and M are parallel, so they have to be parallel. So over here in my picture, I have lines K and M. If they're parallel, then three things are going to be true. A reflection over K and then M is also a translation. Okay, so a double reflection will become a translation. But again, only if those lines, what I am reflecting over is parallel. That's only true if it's parallel. Okay. Then the other thing is that your reflection segment from the very first pre-image to your final image will be perpendicular to those parallel lines. So what am I talking about? If I go back up here, and I look at my reflection segment, let's say from B to B prime, so that, or B to B double prime. Notice, give me 5 minutes. Notice that my slopes of my lines are x equals 0, or I'm sorry, undefined. So my slope of my green line is undefined. My slope of my blue line is undefined, but my slope of my reflection segment is 0, so it's perpendicular. Okay, so they'll be perpendicular. Then the other thing, and this is the coolest part, I think, is that your distance, okay, notice I don't have a bar over my PP. My distance is going to be, or my P double prime, my distance is going to be 2 times the distance between K and M. So what am I talking about with that? Okay. If I look at my distance, if I come back here and I look at my distance from my two lines I reflected over is 6. Okay. I went 3 to the right, 3 to the left of 0, right? So my distance of that is 6. But notice if I go from B to B to B double prime, that's 12. So it's double the distance. Okay. So a double reflection results in a translation that moved perpendicularly double the distance. So I'll say that again and I'll bring it back down to here. So a double reflection over parallel lines becomes a translation that moves perpendicularly to the parallel lines double the distance. Kind of cool, huh? Okay, so let's look at an example that might help us or that we can work with this on this. So it says in a composition of a reflection of A, -4, 6 is reflected over X equals -2 and X equals 1. All right, so let's draw this so we can see it. So A is -4, 6. So A is here. And then X equals -2 is going to be right here. And X equals 1 is going to be right here. Okay, now the only thing that we didn't talk about is that order of reflection matters which direction it's going to end up reflecting. Okay, so let's look at the first example here. If A is reflected over X equals -2, and then it's reflected over X equals 1, what would be the direction and the distance? So I'm going to reflect A, and we're not going to do it. Don't do it. I just want you to think about it. If I reflect A over X equals -2, and then I reflect it over -1. What's my direction and what's my distance? Pause and try and figure that out. Okay, so my direction is going to be that it goes to the right. Agreed? So my reflection is going to go to the right. And then remember, my distance is always double the distance. So my distance here is 3. So double the distance is going to be 6. Okay, so anytime we have a double reflection over parallel lines, the distance of the translation will always be double the distance. Okay, you guys try the next one, but this time you're going to reflect over X equals 1, and then you're going to reflect over X equals -2. So pause the video and try and figure out the direction and distance of this one. Okay, this time we're going over X equals 1 first. So that's going to take my A. If I'm going to flip over the green line, that's going to take my A way over here. Agreed? And then I'm going to go across my X line, which then means I'm going to reflect it over my blue line. So then it's going to come back over here. Does everybody understand what we're saying? So if I reflect over X equals 1 first, it's going to bring my A way over here. And then I'm going to reflect over X equals -2, which is my blue line, which would bring it way back here. So my direction actually takes my point left of my pre-image point. And how far? Still double the distance. Okay, still double the distance no matter what. Okay, so again, how you reflect, how you do the double reflection depends on which direction you go, but you're always going to be going double the distance that direction. Okay. Okay, so hopefully that all makes sense. So with the rest of the hour, you'll show the sub your filled in notes, and with the rest of the block, you can use it to work on either your reflection homework that is still out there, if you'd like to work on that, or you can use it to work on your translation homework. All right. I will see you again on Monday, and if you have any questions, come see me Monday. I hope you guys have a wonderful weekend.